lesson, please watch the video, take notes, pause the video so that you can try it on your own and then check it with what I say. Slides are posted on Google Classroom. There will also be work, like my exemplar with the slides posted. Practice is also posted. But if you have any questions, you can email me at any time. Alright, so today we are going to be talking about simplifying, multiplying, and dividing rationals. So by the end of this lesson, you will be able to understand how to simplify, multiply, and divide rationals. So, just some announcements. Your end of quarter assessment is on November 6th, which is a Thursday. Assessment number 2 resubs are due Thursday, October 30th. Remember, if you fail the assessment, I will have office hours on Monday after school, just for you to come resubmit. Even if you didn't fail and need help with the question, you can come resubmit in office hours. Unit 3 homework is due Monday, November 3rd. Just a reminder, that is before the end of quarter. That is that Monday before. So please make sure you are checking dates and making sure that you are studying for this test. All right, because this is the halfway point between you guys and the January Regents. So please take this seriously. And it will also determine who is an AIB for quarter 2. So if you bomb it, you will be an AIB. All right, so simplifying fractions. When we simplify fractions, all right, clearly there's no one to answer my question, but when we simplify fractions, the first step that you need to do is expand. All right, so what that means is 15 turns into 3 times 5, and 45 is 5 and 9, but we know that 9 is 3 and 3, so this becomes 3 times 3 times 5. So when you simplify, you ask yourself, what can I eliminate? So we have a 3 and a 3, and a 5 and a 5. If everything up top is eliminated, it does not turn into 0, right? Because there is always that invisible 1. So this is going to be 1/3. And you can check this in the calculator, right? 15 over 45 simplifies to 1/3. So this is essentially what we're going to be doing for this lesson, but it's going to look a little bit more complicated with rationals. So rational expressions, please write this in your notebook, is when you take the quotient of 2 polynomial expressions. So here are some examples. All this means is you have one polynomial expression over another, and remember the reason it is division is because it is a fraction. All right. So that is what a rational expression is. Write this in your notebook. Again, pause the video, unpause it to write this down. All right. Next up. So, rational expressions require you to factor. If you are still struggling with factoring, you are going to struggle with this. I will say time and time again, factor, factor, factor. All right. Simplifying rational expressions. So, this is part 1 of the lesson. In order to simplify rationals, your first step always is going to be to factor numerator and denominator. All right, so up top, you're going to use a in factoring because this is a 1. On the bottom, we're going to use difference of squares. So this becomes the factors of 6 are 1 and 6, 2 and 3. 2 and 3 adds up to 5. So it's going to be x plus 2, x plus 3, over x squared minus 4, 2, and positive 2. All right. So now, from here, it is actually very evident to see what is going to cancel out. All right. So that is our step 2. Cancel out the common factors. So up top, you'll see we have an x plus 2, and at the bottom, we also have an x plus 2. So that will be eliminated. And your final answer will be x plus 3 over x minus 2. And that is your final answer. So Just a reminder that you cannot cancel if you do not factor. Alright, sometimes what kids will say is they'll say, oh, I have an x squared and an x squared, I can cancel. The reason you cannot do that is because there is addition and subtraction between each thing. The reason we break it up into factors is because now it's multiplication, right? And just like we simplified fractions, this works the exact same way. We are simplifying factors. Alright. So, factoring is an extremely helpful tool to help simplify rational expressions, which makes it easier to eliminate from the numerator and the denominator. Alright? So, here is practice number 1. Obviously, I cannot set a timer because there's no one to practice. This room is empty. But I'm going to go ahead and run through this. I would suggest pausing the video here, trying it on your own, and then coming back to see what I do. So remember, step 1, factor. Step 2, cancel out. So, step 1, factor. Both of these are going to use AM factoring. This is going to be 2 and 10. So this is going to be x plus 10, x minus 2. And then the bottom is going to be x minus 2, x minus 7. Alright, so the only factor that we can cancel out is this. So your final answer is x plus 10, x minus 7. Alright? Cool. So again, I'm going to move through the practice pretty quickly because you need to try these on your own. Alright. So again, we're going to see AM, difference of squares. Same thing. The bottom one is going to be x minus 2, x plus 2, and this 2 times 1, which adds up to 3. Oh, sorry. Alright, so again, the only thing that cancels out is this, and that is x plus 1 over x minus 2. Now obviously, if nothing cancels out, this can't be simplified anymore, right? Okay, so that is simplifying rationals. It's pretty easy, there's not anything crazy with it. Alright, so now we're going to move on to multiplying. Just like when you multiply fractions, it works the exact same way, okay? So we got 4 times 25 is 100, 5 times 28 is 140. However, there is a strategy we could use that would make this easier, okay? 4 over 5 cannot be simplified, but 25 breaks down into 5 times 5, and 28 breaks down into 4 times 7, all right? So, similar to simplifying, if we break things down first, it's actually easier because we don't have to figure out what 5 times 28 is. Alright, so the 5 cancels out, and so does the 4. So up top we have a 5 left, and we have a 7 left. And we get 5 sevenths. So while they are the same, this is simplified a lot further than this is, right? If you multiply first, you still have to simplify this. Versus, if you did this first, your answer is already simplified. Alright? So, instead of multiplying first, we simplify first, alright, to make it easier. Cool. Alright, so when we are multiplying, your steps are going to be the exact same, right? Because when we multiply, everything can be combined. So what that means is step 1 is again factor. Alright, none of this can be factored, so I'm just going to rewrite it, and we have x minus 2. Remember, when you multiply, it all stays on the same line. So this breaks up into x minus 2, x plus 2, and this is a GCF where I take out an x. So this is x plus 2. All right, what do you notice? Everything is going to cancel again, we don't have 0 left. What do we have that is invisible? The 1. So this is actually equal to 1. All right, so that means that step 2 is to cancel. So again, between simplifying and multiplying rationals, nothing really changed. The only difference was that we just extended that line, right? It's like if I just extended this and added parentheses everywhere. That's literally the only thing that changed. All right, cool. All right, so now we're gonna multiply rational expressions, practice number 1. All right, so pause the video and then try it on your own. So when we see the power of 2, again, steps don't change, factor, cancel out. All right, this becomes x plus 2 times x plus 2. You can break this up, so 6 becomes 2 times 3, but you don't have to, right? Because what you're gonna see is that this and this will simplify as a fraction. So if you want to break it up to see it easier, you can, but you don't have to. And then this is times 3 times x, and again, times x times x. All right? And then x squared minus 4 becomes x minus 2, x plus 2. So an x cancels out, the number 3 cancels out, and an x plus 2. So up top, you have x plus 2, and at the bottom, you have a 2, an x, and an x minus 2. So you can combine those and just write it like this. And that is your final answer. All right, so that's practice number 1. All right. Cool. So now let's try practice number 2. And this one's gonna get a little bit more complicated, right? Because now, here we have AM factoring, AC, AC, AC. Okay? So, I'm going to show one of these, but the rest, I am just going to run through them, all right? If you look at my exemplar online, you'll see the step-by-step on how to factor them. So, for the first one, when we were factoring, remember, AC factoring means you multiply A times C, so this gives you 30. The factors of 30 are 1 and 30, 2 and 15, 3 and 10. The only way we'll get to 7 is with this. So it's 2x squared plus 10x minus 3x minus 15. Split it in half, all right? 2x squared and 10x have a 2x in common, and we're left with x plus 5. They have a negative 3 in common, and we're left with x plus 5. Remember, these have to match. So we're left with 2x minus 3, x plus 5. So that is the first one. All right, so I'm going to write that down here. This bottom one, again, you can see my work online, is going to be 2x minus 1, 2x minus 3. I'm going to extend my line because we're multiplying. And I have 2x minus 1, x plus 1. And then the bottom one, which is AM, is just an easy x minus 5, x minus 1. All right, so what you will see is this and this will cancel, this one and this one. But nothing else cancels, all right? So this answer is going to be slightly larger. It's going to be x plus 5, x plus 1, over x minus 5, x minus 1. All right, so sometimes they will ask you to multiply these and put it back in standard form, but if they don't tell you to do that, you can leave it like this, all right? And nothing else will cancel out. Okay. Last step is dividing, all right? We you're dividing rational expressions. For simplifying, multiplying, dividing, things are going to work the same. The only difference is that when you divide fractions, remember there's a special rule. It is called keep, change, flip. It's like KFC, but not. Alright? So we keep this, and that stays as 2/3. This division sign changes and turns into multiplication. And this flips and turns into 9/4, right? The fraction flips. So when we do this, all right, this can turn into 2 times 3 times 3, because that's what 9 turns into. And then 3 times 2 times 2, because 4 breaks up again. So again, now it's easy to simplify. The 2's cancel out, the 3's cancel out. So your final answer is 3/2. So the biggest thing you need to remember is keep, change, flip. When you are dividing, that's the extra step that you have to do before you can factor and cancel out. Okay? So, let's try this one. Again, it looks complicated. I promise it is not as crazy as it looks. So, with division, this time, it's not just going to be 2 steps. It's going to be 3. So your first step is keep, change, flip. So we keep the first one. We change the division to multiplication, and we flip this. If you forget to flip, it is obviously going to change your final answer by a lot. Alright? Because it's going to change what you cancel out. So, this is the difference of squares, which is x plus 5, x minus 5. This is AM, AM, and AM, which are pretty simple. Right? 16, 4 and 4. You can extend the line because we're multiplying. -8 will be 2 and 4, but the 4 is positive. And 10 and 25 will be -5 for both. So, cancel out one of these. This one will cancel. And we have 2 factors left on top, 2 on the bottom. So, your final answer is x plus 5, x minus 2, x plus 4, x minus 5. And that's how you leave it, because you can't cancel anything else out. Alright. So now, when we divide rational expressions, go to practice 1. Again, pause it, try it on your own, then watch my explanation. So, you can't factor this one, neither this one, but also this one stays the same, right? Keep, change, flip. So change this, and then this becomes flip. Alright? So, cannot factor, cannot factor, cannot factor. The only one you can factor is the top one. Alright? So that becomes x minus 4, 3, x plus 1, sorry, 3x plus 1, because this is GCF. You take out a 3, 3x plus 1. Then 3x plus 1, 2x plus 3. So here, the only factor you can take out is 3x plus 1, right? But if you didn't notice that this was GCF, you wouldn't have been able to take out anything. So we get 3x minus 4 over 2x plus 3. And that's your answer. So remember, keep, change, flip, factor, cancel out. Same thing, right? The only thing with division is we added that extra step. Alright, next practice. Again, a little bit more complicated, but not crazy. Keep, change, flip. So this changes to multiplication, and this flips. Alright, so let's factor the first one. This is AC, and it's going to turn into, again, if you want to see how I actually did this, you can look at my paper copy that's posted in the post. But it's going to turn into 3x minus 4, 2x minus 1. Oh, we're going to extend the line, and this is GCF, 2x, which becomes x plus 2. And finally, this is AC again, which becomes 3x minus 4, x plus 2. So these two cancel out, the x cancels out, and so does the 3x minus 4. So the only thing you have left is this 2, 2x minus 1, and this 3. So your answer would be 2x minus 1 over 3. Alright, you could also write this as 2/3 2x minus 1 if you want to put the numbers in the front, but either one works. So that's practice number 2. Alright, so next steps. Yay, you finished the video. Hope it wasn't too long. Hope you still managed to enjoy it. Alright. There's a practice on Google Classroom. Please attempt at least 10 to 15 problems. You're missing 2 days of school, so please try to catch up that way. Answers are posted. Complete the Google survey, alright? This will be my way of knowing you completed this lesson. I'll add 5% to your lowest summative assessment for completion. I mean, if you don't do it, you're only hurting yourself, alright? On Tuesday, you will have a graded warm-up. If you choose not to watch the video, again, you're only hurting yourself, it will have an impact on you.